is a very simple satellite image from last year for southern India, Kerala and Tamil Nadu. You can see it. The white things, of course, you can figure out those are the clouds, and you can see which areas are vegetated, which areas are barren, which areas are having some kind of coral reefs and everything. So the sediments and everything. So those kind of things you are able to see in this satellite image. So basically, this is what is remote sensing. You're standing far away. Basically, your satellite is far away, and you're trying to observe what is happening on the Earth, on the surface of Earth. Maybe subsurface also we do. So typically, it is from airplanes or satellites. I prefer satellite images because they are recurring and they do it in a very precise manner, right? So, and also one more thing is that why I love satellite images is that it is independent of bias, a little bit of bias. I mean, its biases are known, that kind of thing. What that means is, as I said earlier, if I go to you individually and ask, do you think your place is having lots of trees? Each one of you will have different answers. Maybe it is true, maybe it is not true. But these are very subjective in nature. That is, it changes from person to person. If I ask you questions like, do you think it is hot or cold? Some of you might say it is hot. Some of you might say that it is extremely hot. So it depends on people's perception. But satellite images are independent of that. It just observes. It doesn't have any of these biases. That's why I love satellite images, because I will get the actual data from ground rather than people's perception of things. So, it is a bit technical when we talk about satellite images. If you had physics in your 11th and 12th or however your education system is, if you had studied about light, you would have talked about electromagnetic spectrum, that is light with different wavelength, etc., etc. So that becomes an important thing in your satellite image analysis, because it is similar to what we call as color, right? What do you call as color? Like you see black color, you see white color, you see green color. So what does that mean, right? So basically, if it is green, it means it reflects a lot of green color from its surface. So one type of light, one wavelength of light is being reflected more, so you see green. Another type of wavelength is seen reflected more, that means it becomes red. So that is how science of electromagnetic spectrum is. So this is what we are seeing. So what means is that my hair is black. What it means is that light is falling on my hair and it is not coming out. That is why you are seeing it as black. If everything is being reflected, it will be white. If only some kind of one wavelength is reflected, you will see it as a red or blue or something like that. This is understanding of color. So this is very critical, because satellite images are no different than your eyes or your photographs. So each type of material will reflect different types of wavelength. That is what satellites observe. So it is no different from your eyes or your common photograph. So you can see it over here. Some samples of my hometown is shown over here. So you can see satellites with different resolution. One satellite on the left side is looking very pixelated, one looking very accurate. So you have different types of satellites. It's the same as your cell phones or your digital cameras. Some of your cameras might be great. Some of your cameras might not be that great. You say that more pixels means more clarity, etc. So in the left top, you can see a satellite image that is very coarse and you are not able to figure out what is what. And in the right side bottom, you are having very accurate ones that you can figure out rooftop, what kind of roof it is there. So different images come in, and these have different applications. It's cost of sensor and how frequently you can take photographs, etc., etc. That plays a role. Based on these, we try to observe our changes on environment. This is what I do professionally with respect to remote sensing and satellite images. So this data, what I'm showing over here right in front of you, all these are free. It's open source. You don't have to pay anyone. You just go to their websites, you can get it. So so some samples I'm just saying about what kind of data you'll get it. As I said, there are individual satellite operators. You can get it from private or you can get it from government. Some of them are free, some of them are not free. So some of the sources for open source or free data is from European Union, American government. They all give it for free. Some of them are proprietary, that is, you have to pay for every square kilometer, like from private companies like Maxar, Planet Labs, etc. So they all come in image format similar to your photographs. Your photographs, you get it in PNG, JPG, or TIFF, right? So it's a similar type of arrangement. You'll get it. And there are specific softwares to analyze these kind of satellite images, QGIS, RGIS. QGIS is free software, of course. Then there are cloud computing services also to process these images. Now, this is how we go about with remote sensing. Now, when we talk about climate change, I want to talk about how this remote sensing is being used in this climate change narrative and how are we utilizing it. There are 4 components of this utilization. So first one is with respect to emissions and anthropogenic factors. What does that mean is that climate change, of course, many of you might have gotten an introduction on where it comes from. There is transport related sources. There is energy related sources. So you have so much of emissions that are happening. And other anthropogenic factors like deforestation, etc., etc. You have one component that way. How satellite images can be used in observing them. That is number one. Second is predictive models. Predictive models in the sense, today this is your climate. Today this is the type of climatology that you have in a particular place. And these are the types of risks and disasters you might face. That is the current reality. But what is going to happen in the future, right? That comes under predictive models. And third is attribution science. Attribution science is basically, you might have seen it in the newspapers or news articles, or maybe even the other guest speakers might have talked about it. They all talk about, there is high amount of cyclones because of climate change. There is glacier melting in this particular place. That is so these are attribution. That is, you are attributing some kind of change that you have observed, whether it is weather or whether it is a direct or an indirect effect. You are trying to say that this is being caused by this particular phenomena of climate change. That is attribution science. The fourth one is impact assessment. It can be a common weather phenomena, or it can be a climate change induced weather phenomena, but it will always have impact on your lives. It will have some kind of a change. So that also could be detected. So in these 4, I'll give some examples on how we use satellite images and other data to produce some kind of results. So the first one, as I said, is emissions and anthropogenic factors. So how do we observe it? So you saw a satellite image earlier. Now satellite images, as I said, it depends on object-wise, like the colors that you see on ground. It's similar to your eyes, right? So if I show you smoke, you can identify where the smoke is coming from. I mean, as long as it is clear and it is not hidden, you can always see where the smoke is coming from. And if I show you some form of a liquid flowing down in front of you, you can still figure out its source. The same way, what we try to do with satellite images is that we try to figure out the sources of these emissions. Where are greenhouse gases coming from? Where are other gases that are impacting indirectly these greenhouse gases or other environmental issues? Where are they coming from? That can be observed with satellites. So the one that you see over here is coming from a particular satellite called Sentinel-5. It is primarily used for detecting gases and dust and other things in the air, atmospheric changes. So this image actually shows nitrogen dioxide. Nitrogen dioxide is not a greenhouse gas, but it indirectly creates other greenhouse gases, as well as it is a very good indicator of these emission sources. So this is from an average for 2018 across India. In this map, what you see is that the areas in red are having high amount of NO2 emission, nitrogen dioxide emission. You can see it. So you can see there are lots of red dots in these around West Bengal, Jharkhand, Chhattisgarh, and Odisha. Now you might be wondering why, what is the cause for it, right? So these are all thermal power plants, coal-powered power plants. So people would have talked about fossil fuel burning and everything around that. That is taking coal, burning it for electricity. And this is largely being done in the eastern states. Because this is consumed across India, but it's largely produced in eastern states because that is where most of your coal is found. Coal mines are there and everything. So you can see a lot of that emissions happening from those coal mines. So that is number one. Other places you can see there is a big red dot near Haryana, and there is small red dots occasionally in other places. These are cities. Our cities have a lot of this vehicular pollution, and these emit a lot of these gases. So that could be observed. Those are the red dots. Small red dots. Occasionally you can see it near Chennai, Bangalore, Mumbai, or Delhi. So the Delhi is in the top. You can see a big red dot, right? That is below Haryana. That is Delhi. The words Haryana next to that. That is Delhi, and that is of course you know how much pollution it has been facing. So you can see it from this map. This is nitrogen dioxide. It is not just nitrogen dioxide. We can monitor many of these: formaldehyde, methane. We can do sulfur dioxide. We can do carbon monoxide. We can do dust particles, which is PM 2.5, PM 10 also we can do. So all these analysis we do it, and we figure out which are the sources. We try to figure out these sources. Now there are so sometimes we will be able to figure out the location, sources location, but what exactly is causing it, you need to do a little bit of inference. I'll show some samples based on that. So in these 3 satellite images, you can figure out 3 types of sources. All 3 are linked directly with fire. So the first one in the right side top, what you see is a coal mine. You can see the black coal fields in that satellite image, and there is smoke rising out of it. This is because of a random fire happening in coal mine. This is not just power production, by the way. This is just fire happening within that. In the left side bottom, what you have is crop fires in Punjab. Some of you might have heard about it. Stubble burning. That is, once the farm is harvested. That is, they have paddy and all these crops. Once it is done, the residue will be standing, right? Basically, you would have cut the top, but the residue will be there. That, instead of collecting, they burn it because of some problems with the water availability. The government has restricted the availability of water and everything. Because of that, they don't have the time to collect it and, prepare fodder or something. So since they have a very less time, they have to quickly get rid of it. So they burn it. So you can see that fire and the smoke coming out of it. In the left side bottom image, you can see how much smoke it produces. And in the right side, you can see a very urban environment in Mumbai, where there is a garbage dump. That is landfill sites you have, right? So every day you produce waste from your household and you dump it in some place. And that sometimes knowingly or unknowingly it creates fire. So one kind of that case was observed in Deonar in Mumbai. That is what you are seeing in the right side bottom. So that is garbage dump fire. So these kind of fires are there. So satellite images can be automated also, in the sense like the detection from satellite images also can be automated, and we can figure out where and how many fires are happening in a particular place at a particular time. So this map, for example, in this map, what you see is entire India. The colors show how many fires have been happening. As I said, fires happen for different reasons and at different time. So in Punjab and Haryana, it is primarily crop fires. In East India, it has been primarily relating and power plants related things. In Telangana, you can see crop fires and forest fires. In Nallamala region of Andhra Pradesh, it is primarily forest fire. In Northeast India, it is a mix of slash and burn and crop and forest fires. That is what it is. In Northeast India, they have a shifting cultivation practice. That is, once they start, if they have a crop, they will, once they are done with the crop, they let the forest grow back, and they will move their farm to another place where there will be already forested, and they cut it or they burn it, and they'll farm over there, and meanwhile this place becomes a forest, and later they shift back, etc., etc. This is called slash and burn practice, Zoom cultivation, they call it locally. So that kind of practice is what you're seeing, all these fires. So these, in the 1950s, we have been always having satellites, and particularly the United States has been having some of the longest serving satellites, and we have been fortunate enough to take that data and figure out where exactly forests are disappearing. So in this image, in this graphics that you can see over here, this is a continuous set of satellite images from 1989 to, and you can see forests disappearing in two sections over here, on the left side and one on the right side. This is happening in Assam, and all these forests have now been converted into agricultural land. So this is one type of issues that we are having. Just give me a minute. I'm so sorry for the interruption. That was an election campaign. So these kind of changes you can detect using satellites. So the next is, now that we know what is causing it and where the issues are, the next is predicting changes and predicting effects. Now, this is very critical for us to, plan our whether it's our cities or whether it is our villages. We need to plan better, and for that we need to do a lot of predicting, right? So we need to know where it is going to happen. So the first is we use a lot of models, climate models. So a sample result, I have just kept it in the right side. This one we had prepared for an African city, by the way, Addis Ababa in Ethiopia. So what it is basically we try to figure out the change in precipitation. How much? How much change has been happening? Will happen in rainfall. Precipitation means rainfall. So how much change in rainfall will happen in 2050, right? Not now, but in 2050, how much change will be there, and are you prepared as a city? So the map on the right shows that change that was predicted by the model. Now the models have always been in a question with respect to their accuracy and usability. However, it has been becoming better and better over time. So in this map, what you're seeing is that the areas in red are supposed to have lesser rainfall. Areas in blue are going to increase in rainfall. So this is something that we have predicted, but it may or may not happen because what we have are the best models, but still there could be some unexplained changes as well. So small changes small differences can happen. But still these kind of models have been made available, and because of better computing facilities, we are able to do it better and better. So this is the second type of advancement that is happening. The other is one thing that people always associate with climate change is sea level rise. Sea level is going to rise. And for that, they use what is called as bathtub analytics. Now, I personally don't like this model at all. But many people, I do not know if they had already used it in some presentations or something. But you can find it in every newspaper article, or once in a while you can find it. So in the right side, what you have is a map showing Mumbai, and but this is what is popularly used. I wrote a scathing article against why you shouldn't use it in the past. But anyway, this is one of the maps that you can see. This is one type of predictive modeling. The other is, which I also do, is for extreme rainfall numbers. Let's say your place has been predicted for say 25 centimeters in rainfall, or something extreme that you had never faced in the past before. Then it will cause flooding, right? So we also work on models to predict how much area will be flooded if this much amount of rainfall happens. Now this requires a lot of computing because of these local changes, and we have to figure out each and every bump that is there in the land, there's every small bump and everything. That based on that, we run these models and we try to figure out which are the places that are flooded. Now, this is a sample that I'm showing for Nanjangud in Karnataka. The Kabini River is there, and in the Kabini River, if 2 lakh cusecs of water is coming up, then which are the places that are likely to be flooded is shown in the left side. So that is my model simulation. That is water coming in and side areas close to the river is getting flooded, and luckily, not lucky, but unfortunately, you can say, the place did get flooded in 2019. So in the right side, you can see on the top, areas in black are flooded. It somewhat matches my model on the left side. And you can also see that the roads that are placed in close to the floodplains were also were closed because of this flooding and everything that you can see in Google Maps. So these constitute predictive models. That is, you predict disasters and you use satellite images as well as high amount of computing in that. Now, the next part is attribution. As I earlier said, what attribution means is that a particular type of weather event has happened. It may be, say, cyclone, it might be landslide. People try to attribute it to climate change. Now, personally, I feel a lot, pessimistic about these kind of attribution science, because the relationship is somewhat, sometimes it's not very clear. We don't have much data also, and it is not much clear. But still, people attribute, whenever a cyclone forms, they'll be saying like, climate change or something. But traditionally, our places are supposed to have lots of these things as well. So one of the biggest things about climate change is one thing that we can clearly attribute is glacier retreats. Now, of course, that many glaciers have been retreating. And because of these retreating, they form glacial lakes. That is, once a glacier retreats, this ice and snow melt and they form a small lake. These lakes are becoming larger and larger. Sometimes they burst off, these are like temporary lakes, and they just burst off and suddenly they cause flooding. This is called outburst flooding. This is what I'm showing over here, glacial lakes and outbursts. This is a particular glacier in Sikkim, this map. You can see the snow-capped mountains in the top, and below that there is a glacier that is flowing, that is the South Lonak Glacier. And there are three, it's a combination of three, South, Middle and North Lonak. And these three glaciers have formed a lake below. So that is what I'm showing in the bottom. So you can see that the lake extent has been, every year it has been increasing. In 1968, it was near the yellow line. In 2020, you can see it in the red line. So you can see how much it has grown between 1968 and 2020. 1968 satellite image is the oldest available satellite image for us in that particular place. This 1968 satellite, if you want to know that it is, its name is Corona, by the way. So it was a spy satellite back in 1960s. United States wanted to spy the entire world, and they built these satellites. This is 1968. Imagine how far it is. So when we were still watching, our parents maybe, watching black and white movies, and that is when the first satellite images from 1968 were coming in from the United States. And from those images, we are able to see how much change it has happened over time. So we have, post 1980, of course, we have a steady number of satellite images. So we can see the numbers, how it has been changing. So this is one of the problems, and we can observe that using satellite images. Second is with respect to floods. Now, as I said, the attribution to floods is a very, very difficult one, because in the right side, what you're seeing is that the area in blue is the river Brahmaputra, and the area in red is the area flooded because of a particular seasonal rainfall in 2019 and 2020. Now, whether this can be attributed to climate change or not is a very big question. Because every year I'm observing it. It's not like a new thing that is happening. I can't say that it is happening because of a. I won't say that it is having no impact from human induced effects, but some of these are natural also, right? So this is what is contributing to attribution science, in the sense like figuring out whether a particular disaster is linked to climate change or not. So for that also we use satellite images a lot. The next, of course, is landslides. Now, landslides is a very tricky concept also with respect to attribution. Now, that is an indirect effect. That is, we say that because of climate change, extreme rainfall has increased, and because of extreme rainfall, landslides have been increasing. Now, unfortunately, in India, the biggest trigger and the immediate cause for landslides in many places, at least in 80% of the cases, is not just extreme rainfall, but when some form of a construction activity is happening in the nearby. It is still human induced, but it is not necessarily climate change. So, but anyway, this is attribution science. In the right side, you can see a landslide affected area near Wayanad. And in the, this one is near Coorg. And in the left side bottom, you can see some samples of many landslide cases that happened in Coorg, again, Kodagu district in Karnataka. It's in the border of Kerala and Karnataka. So in some of these cases, it's natural. In some of the cases, it is artificial, clearly artificial, directly artificial. But to clearly say that it is primarily because of climate change has been a problem, but that is one aspect of attribution science. The other part of attribution science is with respect to our cyclones. So cyclone intensification and origin have been the subjects of research in this. Now, this is not very conclusive in India, but there are some indications that the intensity of cyclones have been increasing. The probability of intensification. Now, in this map, what you see is that all these colored points are where cyclones have originated in India, around India. So, places which are having red color dots are maximum, like 10 cyclones have formed in that particular place. Now, this changes between season and other things also. So you are having a very random data somewhat, and we are trying to figure out a pattern in this. To some extent, people have been saying that intensification is happening, but with respect to origin, not much has changed. It is somewhat similar, but this is where another research is going on. We are trying to observe all the from satellite images and other data where exactly these cyclones are originating, because how is it affected? Because for cyclones to intensify, you need a hot, sea surface. For that, so basically the hypothesis is that climate change is increasing sea surface temperature, which is causing intensification of cyclone. So this is how it is going, and these kind of data we are using. So one particular case that we are looking at in this one is Cyclone Fanny, which was 2 years ago, and you will notice that in the right side, so in the left side, what you can see is the route taken by Cyclone Fanny. It originated in the southern Bay of Bengal, close to the equator. So it's between Sri Lanka and Sumatra. You can see it is originating, and then it hit Odisha. It moved, it zigzagged, moved, and finally it hit Odisha and moved towards West Bengal. Right, so it was hitting Odisha. Now, why this is critical is that in the right side you have a set of all the previous cyclones that hit India in the months of April and May. Now, you would notice that not many have taken this path in this time of the year. So, one concern is that maybe it could have been linked to climate change. There is a possibility of it, and the intensification of it. And none of these were also very intense as compared to Fanny. So this is how attribution is done. In the sense, we try to figure out what has happened in the past, and for a particular disaster, whether it was a normal phenomena or not. The next aspect of this, now, you have a climate, let's say whether it is climate induced or not, You're having a disaster in hand, and this causes some kind of an impact to your life and your resources, and whatever it is, whether it is buildings or cars or whatever it is, or maybe electricity. We can figure out using a lot of satellite images. I've just added one particular case. This is Cyclone Amphan. Cyclone Amphan is also similar to Fani. We were talking about whether it was intensifying higher than usual because of climate change, was one of the discussions that we were having. And this was Cyclone Amphan's route, shown in the right side, an orange dotted line. That is the route taken by Cyclone Amphan. And because of that, many places, I mean, because of the extreme wind and high rainfall, many places, the poles, the electric poles, they were all lifted off the ground, and many people lost electricity. So using these satellite images from nighttime, we figured out which are the places that have lost electricity. So the area marked in red are the places that have lost electricity the most. So that we could, I mean, the basic idea was to figure out where you need to help people, right? So this was the area that had lost electricity, and area with the highest impact, of course. And those can be easily observed using satellites. So this is a sample case of how we do it. Same we did with Fani, with Gaja. Every cyclone that has hit, we were able to figure out the area of impact. So local issues beyond climate change. Now, this is a very critical one. As I said, attribution is very difficult, but we do know that certain factors play direct role, and these are happening at a very local level. For example, we talked about climate change induced sea level rise, but the factor is more than that. My usual assumption is, my hypothesis is that 90-95% of the changes that are happening in India are not because of climate change, but because of local, you can say stupid decisions, but local decisions or wrong decisions that are happening at a very hyper local level. For example, this is a port that is being constructed near Chennai. Near its Katapalli shipyard. Initially, it was done by L&T, and now it is being owned by Adani. So when the port was constructed, the coastline changed dramatically. So the red color line in the map is actually the coastline that was there in 1990 before the construction of the port. Then they built the port. In the middle, you can see that the shipyard and port I have marked, that is the port. Because of that, to the south of the port, where I have marked accretion, a new beach has formed because of the sedimentation progress. Waves hit those breaks that have been constructed for this shipyard, and new beach has formed for 670 meters. That is more than half a kilometer. A new beach has formed. And on the other hand, to the north of it, the sea has, come inside or eroded. The land has been taken away, and that has happened for 300 meters. 300 meters or nearly half a kilometer, 1.5 fathoms. That much amount of erosion has taken place because of construction of one port. So now they are asking for no fishing zone and everything. So these kind of decisions alter your coastline more than sea level rise from climate change. Now that is a factor. This is one. Second is floodplains. Now, as I said, we have a very tropical climate. That is, our rivers, once there is heavy rainfall upstream, our rivers rise and it floods the nearby area. And once the dry season comes in, it becomes smaller. And this is a natural cycle as well as climate change induced cycle. But these can be observed using satellite images. How much it changes. So you can see the Bhima River in the summer, how small it is, and during October, during the monsoon, how big it is. We can see a flooded area like sandy and everything. All these are mud flowing in the flood water. Now the problem is these floodplains are being destructed everywhere, particularly in urban centers in like Bangalore, for example. You can see the Belandur-Vartur region in 1984 on the left side. It's having some farmland in between two particular lakes, and that is a floodplain. And in 2016, it has been constructed completely. That means water cannot flow freely. Now, these are the biggest causes for flooding in our urban centers. So here's a sample. In the left side, these are the green is the area that is supposed to be floodplains. That is area when it rains heavily, these are the places that will flood. Basically, you shouldn't construct over here, but we have constructed. So in the right side, what you see is that the area is getting flooded. Now, this is Manyata Tech Park. Many people, I'm not sure if you have been there, but these kind of problematic decision making causes more impact to it. So in the right side, it's a video actually. You can see it like how the area has been flooded. Of course, it will be flooded because it's in a floodplain. Not change, but it is. But people love to say that it is also climate change. I'm not saying that it has no impact, but people love to say it because the municipal councillor, the commissioner, they can always blame this is climate change. I don't have to do anything. It is not my fault, right? That kind of politics is also happening. That is a big problem that we have right now. Other things like, for example, green cover. These are purely planning related issues at a very local level. So you can see a small section in Delhi over here. It's completely lacking vegetation. It's completely unplanned. There is no vegetation in the left side satellite image. You can't see a single tree over there. The right side map shows these places which are not having trees in red color. Now, this means extreme heat. It's concrete. It's purely concrete and tar. That means your heat is going to increase a lot. So once I actually did a computer program to walk in Delhi, basically in the northeast of Delhi, you can walk for 10 kilometers in a line without seeing a single tree, right? So that kind of a problem is there. And because of that, it will increase temperature. This is an analytics that we did last year for Mumbai. Basically, we detected from satellite images how much vegetation is there in each ward, and then we tried to figure out the temperature using satellite images itself. So the satellite image on the left side, you can see how much temperature is there. We have marked 36.5, 31.5 degrees, etc. So in that you can figure out like which are the hot spots, etc. So vegetation are becoming hotter and areas with vegetation are slightly cooler. So how do you construct, etc.? These are localized ones. This is not climate change. This is purely local. So in the right side bottom, you can see a graph that more the vegetation, the lesser the temperature. And these are known, but we try to figure out where it is happening. It doesn't mean that we are not doing anything about it. Sometimes we do stuff, but the problem is what are we doing, whether it is right or wrong. So for example, in Kosi River in Bihar, the government, even now, it still believes that building embankments, that is walls on either side of the river, it will stop flooding. This was the basic thought they had. So they built walls across these rivers everywhere. These are called embankments. But the problem is inside the wall, whichever places are inside the wall, the flooding became more. And the water from outside could not enter inside because there is a wall. And places where you couldn't construct a wall, flood was being transferred over there. Basically, these walls are of no use. Basically, engineering is not helping. You have to understand the physics behind these flooding and everything to provide solutions. That is where the concept is. So these satellite images, you can see it over here in the top. Inside that wall, the red color line is the wall. And inside that, there is a village that has been caught and it is severely flooded. Instead of reducing the floods, the wall has increased flood inside it. And in some places, like in the second image, walls, of course, they break once in a while. When you have thousands of kilometers of wall, it will obviously break. I mean, some of you might have remembered that dike story in Netherlands with Peter and how he puts the finger into the wall to save it, etc. It is the same problem. But it always happens. It is not controllable. And because of the wall also fails and it causes floods in many places. That's what you see in the bottom satellite image. So this is informed decision making. I'm giving you information for that so that you can make decisions out of these. And this is Kosi River. In 2008, it broke severely, and you can see two satellite images before and after. And after breaking, you can see a new yellow color line coming from top to bottom. These are all flooded areas. Thousands of people died. This is where engineering hasn't helped at all. It's not about building walls. It is about how do we adapt to these things. That is where the solutions lie. Sometimes, because of wrong perceptions, people think that planting trees is always helpful. No, planting trees is not the solution to this. Remember, it is as I said earlier, natural vegetation has been on decline. Artificial vegetation has been on rise. Now that is a big problem. It is fueling climate change also. Now this natural vegetation can be thorny bushes. It need not be trees. People imagine that natural vegetation or good thing means it's forest, thick forest, dense jungle, big trees, this much, that much, completely green, etc. But that is not the case. In reality, you need to have grasslands where it should be grasslands. You need to have thorns where it should be thorny shrubs. You need to have deserts where it's supposed to have deserts. That is natural. So if you are going to Munnar and if you are going to see Neelakurinji, it has to be a grassland. It shouldn't be a forest. It should be a grassland. So, but in 1980s, this is where the decision making comes in. 1980s, the government thought planting trees is helpful. And what they did was, in Kodaikanal, in TN, they completely transformed that place into a forest. What you can see is that after some time, it was uncontrollably growing into a forest. Now, because of this, there is water problems in that place. And also, many native Neelakurinji flowers, bisons and everything, they are losing their habitat because they are not adapted to this kind of forest. They want grasslands. Now, so what it means is, what I'm trying to say is that your solutions should be based on data. Your solutions should not be coming from perceptions. It shouldn't be like, we need to plant trees everywhere or we need to build walls to protect us from floods. No, that is not the case. We have to understand everything in depth from bottom to top. And solutions could be varying. It could be, it need not be, we need not control everything. We need to just adjust. We just need to walk on the side rather than taking the steering wheel all the time. So we need to adjust and we need to figure out what are the solutions for it. We need to reduce our emissions. We need to reduce other impacts that we are causing that are having higher impact also. And those are the kinds of solutions I would like to have, not just planting trees or building walls, etc., etc. So these are the things. So satellite images, as I showed, like from top to bottom, it helps you to understand what is happening. I myself learned it from that, and I suggest you to look into these data sets and figure out how environment is changing in India and provide better solutions for your, either for the central government or local government provides solutions. So this is what I do for a living. I take these data sets, I prepare narratives out of it, and then I give it to the government so that they don't take wrong decisions. So this is my presentation. You can always reach me in Twitter also. You can mail me also if you want it. If you have that, you can always ask. Yeah. Thank you, everyone.
Thank you, sir. Participants, if you have any queries, you can unmute your mic and ask your question to the resource person. You can also use the chat box to ask questions.
No questions. That's great.
I think there is no question, sir.
Great.
Participants,
if there is no
If you have any doubt, you can ask now.
Mr. Rao, it was very nice. You have made linked the GPS as well as present situation in a nice way. And I think you have used Fuji, I guess, if I'm not wrong. But I have only a concern that how can we access this presentation?
The presentation, some parts of it is not open, but most of these images I posted in Twitter, so you can find it there also. Part of these images and inferences from that. But if you want as a separate presentation, I can share it later.
Yeah, separate presentation, because in Twitter we can collect each and everything.
Sure.
And I thanks for your sharing. And one query I do have. This is exactly about the Bihar story. What you are saying about construction of walls next to the river. May I know actually what is happening and how what they are doing about this?
So the thing is, the embankment system started around in the British era initially, and it became bigger in the 50s and 60s. And now it has been like almost all the rivers they are planning to build walls on the side. The problem is also when we produce new solutions to the governments, every year it is flooding. Even after construction of all these walls, it's still flooding. But the problem is the engineer has a fear also. Like if I give them a new solution, they are like, will it cost more? Right? Or the money issues, like you're asking me to take away so many things. Where will the money come from for these projects? And they instead what they want to do is let it continue. I don't want to do much. So there is a fear, legit fear. I mean, change is something that you need to have. You need to have a heart for it. You need to be a little bit bold about it. But many of them are like, I don't want to take any risk. If it is bad, let it be. Others have followed that for 40 years, but I'll just continue with it. That is the common narrative, and they are talking about it. Many are talking about these things, but they are not ready to take the decisions. That is still, I think it needs a little bit of a push or a catalyst. That is not yet happening. Engineers in a private chat or in a conference or something like that, they always mention that they accept that this is a problem, but the next level changes is not happening yet. Maybe it will happen, but yet it's not. Thank you. I hope it answers. We have to. I didn't get the question, but so I'm not sure of the whatever is asked in the chat box. I'm not sure of that. But if my subject is too much of, I tried my best to reduce the science and tech part of it. But anyway, this is something that you can always explore. If you have any doubts or anything related to that, you can always mail me or message me. Describe this as that. I don't understand. Anyway, sorry.
Thank you, sir, for your presentation. Thank you very much for giving an insight on the technologies used for observing climate from the space and the importance of observing our climate from the space. Thank you, sir. Now we are going to move on to the organizers to handle the rest of the sessions. Thank you.
The questionnaire section is over now. I welcome TSW Ganga for a vote of thanks.
I like to express our sincere thanks to Mr. Raj Bhagat P for giving an excellent coverage to his topic, observing environmental changes from space. Thank you so much, sir.
Thank you. Thank you, everyone, particularly the organizers and the
The
managers.
morning session is over now. We will go for a break. Kindly come back and rejoin at 11:30. There will be a paper presentation. Thank you, everyone. Welcome, Rahul.